GM everyone, and welcome to today's class. Today, we'll be learning how to build Cairo components. Basically, Cairo components are modules, reusable modules you can plug into your smart contracts. Think of components as like I say, reusable modules, right? If you are conversant with other programming language, let me use JavaScript as an example. We have classes, right? Object-oriented programming, we have classes, and when you have a code you want to encapsulate that does like related functions, you can abstract that logic into like a class. And whenever you want to do something, for example, let's say you're building a payment method, right? And you want a module that handles checkout, right? You can build a class that handles everything that has to do with checkout in your payment system. And whenever you want to handle anything checkout related, you use that class. So it's kind of the same concept with Cairo components, right? Whenever you have like a logic that does related tasks, for example, I'm sure we know about OpenZebelin library, right? And they have a lot of like components there and contracts that we can just import into our code and use. So in OpenZebelin, for example, now we have an enable component there. And whenever you want to implement enable features in your contract, you simply just import enable component to your contract. And just like that, you have the features that comes with like that component. So that's basically an overview of Cairo components, and we'll be diving deep into how to build our own custom components and how we can integrate them into our smart contract. So like I said, components are reusable modules. Think of it like Lego building blocks. Yeah. So each component, how do you define a component? Component, it's usually a part of a system, right? So whenever you build a component, you can simply plug in into any smart contract you want to utilize that component in. That's why they say think of it as Lego building blocks. And components cannot be, unlike contracts, components cannot be deployed independently. Right now, you write a contract, it's a smart contract in Cairo, you can deploy it on the blockchain, right? But when you write a component, you can't just deploy that component. That component has to be embedded in a contract. And whichever contract you embed that component in, the component becomes part of the contract by code, the ABI, right? So if you have a particular function on your component that does like a particular function, right? When you are embedding it into your contract, you don't necessarily need to define another function for that. That contract will have access to the functions that are defined on that component. That's what I mean by the component functions become part of the contract ABI, right? And one advantage of using components is consistency, right? You have 3 projects that have a similar logic in them. You can just abstract that logic to a component, and you can use that same component over multiple projects, and it will give you like the same result, provided you have like tested your component extensively. Okay, so let's go over to the structure of a component. So the first thing to notice in the difference between a contract and a component is the module decorator. When you are creating a contract, right, you decorate it with the hashtag square bracket Starknet contract attribute, right? But in the case of a component, you replace contract with component, and that will tell the Cairo compiler that this module is a component, right? So basically, every other thing is not every other thing, but most things remain the same. For example, your storage variables are the same in the contract. Your events are the same in the contract, yeah, and your interface as well. You have to define an interface for your component, right? So that's the structure. Moving on to events, just like contracts, your components can have storage variables, right? And you basically declare them how you declare your storage variables in your contract, right? With the storage struct, and you can have as many variables as you want. Likewise, the events, you can have as many events as you want in your component, and you declare them just how you declare events in your smart contract. Okay, for now, just like our contract in Cairo interfaces, right? And those interfaces expose the API of the contract, right? So in a component too, you need to define an interface that exposes the functions you want to call from outside that component. So you basically do it the same way you define an interface for a contract. Use the hashtag square bracket Starknet interface. And when you want to implement the interface of that, the interface defined for your component, you use the embeddable as name. What this attribute decorator is telling the compiler is your component is embeddable by any name specified. Name here is just a placeholder. When we build our own component, we'll see how it's used. So name is a placeholder here, and whatever name you specify here is the name you use to Okay, you have a question? Embeddable. Components can be embedded in a contract, right? And the way it's done is you can have implementation blocks in your components, right? So those implementation blocks, each would have an embeddable as attribute decorated. Each will be decorated by an embeddable as attribute. So if you go to the standard ERC20 component implementation of OpenZebelin, they have several implementation blocks. And each implementation block was decorated with the embeddable as. So depending on the particular implementation you want to use out from that component, yeah. Are you getting me? So whenever you want to use a component that it's not written by you, right? You go over to the component. When you study it, you take note of the embeddable as. Let's say that's the only implementation you need. So when you're embedding that component in your contract, you just simply specify the name inside when you are defining. We'll see how to define components in our contract. But for now, just keep in mind that whatever we specify here when we are building our components as a name is what we can use to embed our components in our contracts, right? So when we go over to the contract side, integrating our components into our contract, you get a better understanding of how the embeddable as works. Yeah. Generic parameters. Our components has to be generic over any contract. So for that, we use T contract state, and T contract state is just like telling the compiler, okay, these components can be embedded in any contract, and if to inherit the contract of that contract, and if you have, yeah. And the last thing is, before you want to integrate your components in your contract, you have to test it extensively to be sure that it's working as expected. Okay. Okay, now moving over to how do we use our components in our contract? The first thing we need to do is we need to import it in our contract, and to do that, we use the component macro, and this defines the components we want to use in our contract. For this lesson, I built a simple whitelist component that allows admins to whitelist addresses. I'm sure you guys have, when it comes to airdrops, whitelist and stuff like that. Yeah. So we are going to build a basic whitelist component to explain the concept. So and the component macro takes in three arguments, right? It takes in the path, it takes in the storage, and it takes in the events. So the path is the path to the component to define. We are going to bring it into the context of our contract using the use, just like import from Starknet and your core module, right? I'm going to specify a storage. This can be any name you want it to be, actually, it doesn't matter. So in this case, I use whitelist. And we also need to specify our events, which is, in this case, we're using whitelist event. The next thing we need to do is we need to embed our components into our contract. So this is where it is done here. You notice this ABI embed, this exposes functions in our contract ABI, right? So if we omit here, this implementation will be exposed, right? Our contract. So this is very important. You want to use this whenever you want to expose a particular implementation of the components you are importing outside your contract. And this decorator here doesn't have effect on this next line, internal implementation. if you wanted to expose this, we have to like duplicate it under the, just before the implementation block. Are you guys following? Okay, after we have embedded our components into our contract, the next thing to do is to declare a sub-storage for our components in our contract. So this is how it is done. In our contract storage struct, we use the sub-storage. This is telling the compiler that we are embedding a component into our contract. Yeah, and we specify the, now this name here, whitelist, has to be the same as this name you specified here. But it can be anything, but it has the same thing. And the type is whitelist component storage. So this is telling our compiler that this whitelist variables we have declared in our components will be a stable storage in our contract. So these are some real use cases of component. Like I said, I built a basic web. So what are the best practices when you are building components? I'm sure most of us are solid like principle, right? So one of them is single responsibility. You want to make sure that each component you're building does one particular thing. You can't have a component doing two things at the same time. It doesn't make sense. So always ensure your component is doing one thing. If your component is meant to handle ownable features, let it handle ownable features. If you want another component to handle whitelist, you build another component for whitelist. I don't know if you're getting it. Yeah, and ensure your components, like your functions, your APIs are documented correctly. And you want to make sure that you are tracking every change in state of the blockchain through events. And the last thing, you want to test your components, right? Like testing in smart contracts cannot be overemphasized. You have to test your components to ensure that it's working as expected. So I think that's basically it on, like, this is just like a brief overview to walk us through what we'll be like diving into. So let's move into the coding aspect. So I already scaffolded. Can you guys see the screen, or should I make the font a bit larger? Okay. So this is our component. Like I said, I've scaffolded the file already, the project already. So in our storage variables, yeah, we have two storage variables. We have a variable called admin that would be the admin, like person with admin responsibilities of the component. And we have addresses, which is a mapping of contract address to a Boolean. So basically, when we are writing to this address, it's going to, whenever we read from this address, when we pass in an address, it's going to return true or false based on if the address is whitelisted or not, right? And we have a couple of events here. We have the address added and the address removed. So this event should be emitted anytime an address is whitelisted or removed. So let's go over to the implementation block. So here we can see the embeddables I was talking about earlier, right? So now this implementation block here, although we have not implemented it yet, any function we define in this implementation block will be embeddable in any contract using this name here we specified. Here I'm using whitelist components, right? So after we have decorated that, we need to define our implementation. And this is like the implementation block. This is the syntax. Implementation is generic over T contract state, and we have to implement this has component to it. So our contract knows that we are embedding a component, right? And we are defining it over a trait, right? What is the trait? I whitelist. This is I whitelist. This is the trait here I defined for our whitelist component, and it has three functions. A function for adding to the whitelist. It takes in a reference to the contract state, which will be inherited from the contract we're embedding our component in. That's one key thing to note. takes in the address, which is a contract of type contract address. We have another function for removing from the whitelist, takes in a reference as well to our contract state and as an address. And a last function is whitelisted that checks if a particular address is whitelisted. So let's see how we can implement these functions. Let's start with add to whitelist function, right? This function returns, okay, it doesn't return anything, so this should be complement state t. Right. Okay. Now, whenever this function is called, right, we want to update the mapping of our whitelist addresses here. So how can we do that? We're going to say let whitelist addresses equals, so now we're going to read from the storage, right? Self dot the address. Okay, so let's proceed. We are trying to implement this add to whitelist function. What this function should do is whenever this function is called, it should update the state of our whitelist addresses, right? So I think this should do it. Essentially, when you call this function, you update the whitelist address mapping with the address you are passing into the function. Right. So the next function to implement will be to remove from whitelist. So let's just copy the function signature. We need to replace this with this. Okay. This is the implementation for our removed from whitelist function. So essentially, we are setting the mapping of the address from true to false, right? The next function will be a function to check if an address is whitelisted, right? So we just need to return this, sorry. So whitelist. Yes, and with that we have implemented whitelist components over this trait we define here, I whitelist trait, right? So if we can notice, we are not yet implementing any check with our admin. Right now, if we embed this component into our contract, right, anybody can whitelist addresses, right, because we are not checking if the person calling the function is the admin, right? So to do that, we are going to use an initializer function. Okay. Is whitelisted? Yes, it returns Boolean. It returns a Boolean value. I don't get you.
For the add whitelist and remove from whitelist, so that is true and false, and go to
line 47. Yes. A mapping is a key value pair, right? You're mapping a key to a value, right? So when you are writing to a mapping, you have to provide both pairs. You have to provide the key and the value. But when you are reading from a mapping, you provide only the key, right? So on line 55, we are reading from the mapping, so we provide only address. And what this is going to return is going to return a Boolean, which is either true or false. Do you get it now? Okay. components, like contracts have constructors, right? And constructors are called only once on deployment, right? But components can't have constructors. So one workaround here is to use initializer, and you want to call this initializer in the contract, in the constructor of the contract you are embedding your component into. That way, the initializer is called only once. Are you following? So when we embed this component in the contract, right, we want to call the initializer function of this component and set the address of this admin here, right? So to do that, we will define an initializer function in our internal implementation. Yeah. Let's get rid of this for now, right? So now what this function does is, when the contract is deployed, it calls this initializer and it sets admin to whatever this thing address we pass, whatever the address is of the person deploying the contract. Are you following? Okay. So next we want a function as well to check, to assert the access of the person calling the function, right? And let's call that function only admin. Let's just use the auto completion here. And what this function does is it reads the address from storage, the admin address from storage, and it asserts that the caller is equals to admin, right? If it's not the case, it reverts, it throws an error. So now we can use this function, right, in our components to assert access to our function. So here, right here in our add to whitelist, we can say self.onlyAdmin. And we're passing in the caller address, right? So this will call this function here and check if the person calling our component, our function, is the admin. And we want to do the same thing in remove from whitelist, so that no one can just remove addresses from our whitelist. And I think with that, our component is ready. I'm surprised no one is asking what this generate rate is. Are we familiar with this? Okay, we're familiar with generate rate. Okay, that's good. But in our internal implementation, take note of this. We also need to derive this hash component trait in our components, right? In contracts, we don't need to do this, but in components, we need to do this. Okay, let's move on to our whitelist contract now. So this is the contract we are going to be embedding our components into, right? So remember, the first thing we need to do is bring our component into context, right? So we're going to use create. Whitelist component. The next thing, let's go over to our slide. Okay, so now we need to use this component macro to define our components in our contract, right? So let's go over and you can see components. Part. The part has to be this, the whitelist components we imported here. So we paste that in. Storage, we're going to call that whitelist. Event, we're going to call that whitelist event, right? So the next thing to do now, don't worry about these squiggly lines we're getting here. This is because we have not added whitelist to our contract storage, and same thing with the event. So the next thing will be to embed our components, implement whitelist, implement whitelist components, whitelist components, contract state. What's this? Okay. Okay. So remember, in moving on to our components, we define our components to be generic over the contract state we are embedding our component into. So that's what we're essentially doing here on line 8 by passing in this contract state. Now this component will inherit the state of the contract it's embedding into. So we also need the internal implementation of our component. So we're going to bring that in by doing that on line 9. Okay. So this will allow us, this particular line of code here on line 9 will allow us to call the initializer function in our components. Remember, this is defined in our internal implementation here. We don't want to expose it to the outside. That's why we didn't define it inside our embeddable implementation, right? So when this whitelist contract is deployed, right, only this implementation will be exposed to the public. This internal implementation on line 9 won't be exposed. This is only accessible within our whitelist contract. I don't know if you guys are following. Okay. So the next thing to do now will be to define our storage variables. And to do that, we use the substorage decorator, and we specify the path to our component storage using this syntax. Okay, we have embedded our component storage. The next thing to do is to whitelist events, yeah. Okay, so with that, we have successfully embedded our components into our contract. I've not done one thing. Who can tell me what that is? If you have been following, you should be able to figure out what I've not done. I left something out. Although this implementation is complete, but because of an additional feature added to the components, we are missing a step. Exactly. So we are going to call the initializer. Very good. So first of all, we want to get the deployer. We're going to use get caller address. Then okay, so in our constructor here now, whenever we deploy this contract, this would automatically initialize our components and set the admin to the caller of the deployer of our contract. So this is just a dummy function I created that would allow us to test our component implementation, right? So this function now should be callable by, let's say this is a function to claim an airdrop, right? And we want this function to be only called by users that are whitelisted, right? So in our function here, we can see let's caller assert is whitelisted caller, and if this is not the case, we revert with this error. So if an address is whitelisted, we'll just return this success, just like a dummy something, right? So let's go back to our whitelist component. We have this function here, whitelisted, right? And returns true or false based on if the address is whitelisted or not, right? So in our contract, that's what we're using here, right? So you notice in our contract now, we are not explicitly calling add to whitelist, remove from whitelist, right? But when we deploy this, we're going to see that in a moment. When we deploy our contract, we'll see that these functions, add to whitelist, remove from whitelist, would be accessible from, like, you can call it on Starknet or Voyager, right? And this is possible because of this line of code here on line 8 and 9, right? ABI embed exposes the function in a particular implementation, right? In our contract ABI, right? So I think we can move over to, we can deploy this contract now and test it and see how it works. I don't know if I need to bring. I think I'll need to bring. Some foundry. This. This. Okay, so. Okay. So let's first of all build our project and show that it's building properly. Okay, we don't have any build errors, so we can declare our contract now. SNcast, I think we need to pass in profile. What's the profile? Bravos. Declare. What's the name of our contract? Right. Don't need to pass in fee token. Let me use Stark. Oh, sorry. Contract name. Okay. Okay, we have successfully declared our contract, so we can deploy it now. Deploy. This would be search. Data. Are we passing anything in the constructor? Okay, we're just getting it from. It took out feature token. Okay. Let's go to stack scan. So should be on Sequoia. Let's give it a bit of time to index. Right. Sometimes it takes a while. Hope I copied the right one. Okay. Okay. I used SNCast and I used SNCast basically. So you, first of all, you declare to get the class hash, then you deploy. Right. This is the command to declare. This command is shorter than like, because I am using a default. I'm using a profile here, like in my SN Foundry, right? So if you are not using this, you need to pass in all these variables, like all this URL, like independently, right? So I'm using this profile, and this is like you need an account to deploy it, right? To interact with the blockchain. That's the reason for this. So when you have set this up, right, you can then call in use SNCast by profile and passing in this bravos here, right? And I'm passing in the command I want to carry out, which is declare. Then I need to pass in the contract name. So this is all you need to declare your contract, and you get the class hash. So if you are to open this account file now, right? So okay, this is the account I'm using to deploy. Yes. Yeah, I deployed on mainnet. Hold on. Okay. The app is mainnet. Not mine. That's why it wasn't indexing. I think I need to deploy. Let me just deploy it on Sequoia. Yes, but now profile, setting up this profile, right? It just saves you the hassle of having to enter the URL every time you want to deploy, right? So now you have to pass in. If I don't have this in my SN Foundry, I have to pass in the account I want to use to deploy, right? And I have to pass in the URL. But if I have this set up in my SN Foundry, right, I can just pass in the profile, and it will come here and automatically pick the account and URL variables. Right, so I think I deployed the last one on minutes. Let me declare and deploy on Sequoia. Bravos not found on the alpha. Sequoia, okay. It's supposed to be nope. Bravo Sequoia. Okay. I think I just exposed my private key. Yes, there. Okay, let's copy the class hash again. This is declared now. Okay. Okay. So this is our deployed contract, and if you go over to read and write, you can see we have a read function here is whitelisted, and this is coming from our components. Remember, in our contract here, we didn't explicitly define an is whitelisted function. Rather, that function is coming from our whitelist component, right? So we can pass in an address here. Oh, you don't have, okay. Oh, bravos. Oh, I forget this password. Okay. We can pass in an address here and it will return true or false if the address is whitelisted. Right, 0 like means false, right? Yeah. So let's try whitelisting an address. Let's go over to right. For that, we need to connect our wallets. Let's use our Bravos. Okay, this is the account I actually used to deploy the contract. So this account is an admin. Let's try with an account that's not an admin and see what errors we're going to get. So let's come here. Plus. Okay. Stock's gone. Okay, let's go back to Sequoia. Overview. Let's copy this. Space it here. Do I have my agent here? No, I don't have agent here. Space. See, are you kidding me? I think I had this thing here. What's wrong? Okay, this should work. Okay. Okay, so I've connected another wallet that's not the admin. Let's try to add an address that's not whitelisted, right? Okay. Right. Okay. So we are getting an error here, although I think Bravos provides more verbose error messages than this, but this is actually failing because the account we are using to sign the transaction is not an admin. So that's a whitelist component reverting. So let's try again with the account, the address of the account that's an admin. No, not this one. Bravos. Approve. And let's try to write again. What's the problem? Okay, color is not admin. This is my contract. This is the address. Okay, let's modify our contract to let's pass in an address admin, right? Instead of getting the caller address, let's set it to this admin here. Starknet. Okay. Let's clear this and to pass in instructor called data. I need to pass in this in. Oh, see now. Oh God. Okay. Okay. Let's get this. Contract address. Okay. Test it here. Okay. So I had to deploy another contract because I think the caller was getting mixed up. So let's try again. So this should fail because I'm going to use an account that's not an admin to sign, right? Right. So this is failing. This is unexpected behavior. So let's try with an account as the admin, right? Okay. So you see, we are not getting any transaction errors anymore. So signing this transaction means we are going to whitelist this address. So let's go ahead and sign. Why is it taking this long? Okay. Finally, it's successful. So let's confirm by calling is whitelisted function. Excuse me. Right. Query. See, we are getting a result of 1 now, which means the address was successfully added to the whitelist. So let's test with another address. Let me copy this one. This should be 0. Okay, this is 0. Let's call our whitelist function. This function allows only addresses that have been whitelisted to call the function, right? So let's call it with our account that has been whitelisted. Let's connect it. Bravos. Right. See, it's allowing us to sign the transaction, right? So this essentially means the transaction went through. Let's try it with an account that's not whitelisted. Let's connect the other wallet. That's right. You can see we are getting an error here, which means let me reject this. Close. which means this logic here in what this contract is working as we want to expect. This is asserting that an address is whitelisted before moving on to the next execution. So this is basically how we build components and use components in our smart contracts. Just think of components as reusable modules. You can abstract related logic into, and anytime you need that logic, you just import it and embed it into your contract. So does anyone have any questions? Okay, what's your question? Yes. 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 Okay, let's go over to our contract. Here I find our interface for our contract, right? Starknet interface. Pub trades. This contract. And here we just want FM whitelist function, right? Ref self. Oh, okay, I forgot to. It's supposed to be T contract state. It's supposed to be T contract state. Mm-hmm. Okay. Thank you for that. Okay, so we can use super, right? Now we can come over here and say, we can copy this, right? Now we can say pub imp like this. Nope. I need to call this. I can just get this logic from here and paste it in. This is contract state. Nope. We need this actually. Contract state. So this is the same thing. But now I'm. Oh, sorry. Okay. Now. Can you see it? So this is the same thing, but in this case, I'm using an implementation block, right? So you can embed as many components as you want just by doing this. So let's say you have another component you want to embed. You can just like do the same way. You paste it in and the name of like as many as you want. Do you understand it now? Okay. Any more questions? Yes. You can store it wherever you want to. You can store it in a GitHub repo. You can store it on your local machine. But provided you have access to the components, you can always import it into a project you want to use it. For example, OpenZebelin, they have their repo where they store their components. So you can create your Cairo package define as many components as you want in that package and host it on GitHub. And whenever you want to use any components for that from that repo, you can just import it the way you import OpenZebelin components into your contract. Yeah, you can basically do it like that. Hello guys at the back, are we following? Line 15, okay, yeah. Yes. Okay, 16 is bringing into context the internal implementation of our components. Remember, we have this implementation block. This is the one we are exposing in our contract API, right? But this is our internal implementation, and like the name suggests, right? Internal. We don't want outsiders to call this function. In our internal implementation here, we have two functions. We have an initializer function and we have an only admin function, right? So we are using this only admin function in our component to check if the caller is the admin, and we are using this initializer function when we are embedding our components to initialize the admin, right? So we are calling this initializer function in the constructor of the contract we are embedding the component into. So the initializer function will be called only once, right? And after that, which is when you are deploying the contract, right? So this is what is enabling us access to the implementation. If we are to comment this out, we should get an error here. Here you can see, let's hover over this. Method initializer not found. This is basically because we didn't bring the internal implementation into the context of the contract, right? So that's the use of this line. Any more questions? No, it's not working. If you want it to work for line 16, you have to do something like this. Right? It only works for the immediate line under, and you can't even do it because there's no trait for it. So you can see it's showing an error. So just to recap, right? Components enable us to build reusable modules that we can plug into our contract. If anyone here wrote earlier versions of Cairo that didn't have components, it was like a pain in the ass to write. Because if this simple logic I just wrote just now for whitelist, if you wanted to use it in 10 projects, you have to write the same thing in 10 projects, right? So that's the problem components is solving. If you have something you use across multiple projects, you just abstract it out into a component, and whenever you need that particular function, you import it into your contract. Simple as that. Can anyone give us a recap of what we have covered today? Anybody? Diana, the only lady in the class, do you want to go? Just say anything. Okay. Okay. Yes. Okay. Okay. Okay, so why did we have to do a component? Right? What's the importance of components in Cairo when you're writing smart contracts? Okay, let me help you out. So prior to Cairo, to later versions of Cairo 1, before components were introduced, right? There was no way for you to write reusable code. Basically, you have, if you want a particular feature, you have to implement it as many times as you want in as many projects as you want, right? So Cairo 1 came with components that allows you to write reusable modules that you can plug into your smart contract, right? To avoid, because you remember in programming, whenever you are writing something over and over again, it's error prone, bug prone. You can easily introduce bugs into your smart contract. So with components now, once you abstract your logic into your components and you test it and it's working as expected, each time you are embedding that component into any contract, you are guaranteed to get the same result, right? Each time you embed an ownable component from OpenZebelin into your contract, you are guaranteed to get the features that come with the ownable components from OpenZebelin. You will not get features from an ERC20 component. To do that, you have to import the ERC20 token component. Do you guys understand it now? Yeah, okay. So that's the major importance of components in Cairo. Does anyone have any questions? Or does any guy want to give us a recap? I think Diane has given us as she's tried. Sorry, I didn't see her. I thought Diane was the lead in the class. I didn't see her. I thought Diane was the lead in the class. Yeah, okay. Do you want to go? Yeah. Oh, sorry. Sylvia. Okay. Yeah. Yes. Yeah. Okay. I think that's basically what we cover. That's like a very good summary. So to get, I've done my part, right? I've introduced you guys to components. The only way to get conversant with it is to practice. You have to you have to use it time and time again to get this thing. So during your spare time, feel free, go to OpenZebelin. They have a lot of components. They have ownership, they have access control, they have ERC721 components, ERC20 components, governance components. Like, go look at what they're doing. Maybe if you are working on a project that you need OpenZebelin, try and import OpenZebelin into your and see how you can integrate it and just play around to get an understanding. And if you experience any difficulties, feel free to reach out to me. I'll be glad to put you through. Yeah. So okay. Yeah, sure. You are all on the Discord channel, right? Okay, I'll drop the slide on the Discord channel and the code for today's class. You guys all have access to the Cairo Bootcamp GitHub repo. You can find it on the components branch, right? Yeah, everything we did today exactly, it's on the component branch, right? So thank you guys for your time. It was glad taking you guys.